CloudDB, shaping your new normal.
Welcome everyone, wherever you are around the world, to the 2022 APEC OCI Days by Apaco UC. This is our first year having a dedicated OCI event, and it's our honor and privilege to run this event with the support of 15 Oracle user groups in JUGS in the Asia Pacific region. Please remember to register to as many sessions as you can. This way you will be able to access all the replays until June 15. Basically, you register to the sessions, then you can go to your attendee tab. You will see your own individual schedule, and you will be able to see the replays of the sessions you miss or you want to watch again 24 hours after the live session is concluded. I would like to say also thanks to all Oracle user groups and Java user groups that made this event possible, and also to our sponsors, the Oracle ACE community, the DevRel team, and our main sponsors, Oracle Corporation and CloudDB. Now for today's session, Oracle Database Attack Surface Reduction by Daniel Morgan. If you have any questions to Daniel during this session, please feel free to use the chat window on your right lower corner of the screen, and Daniel will be answering our questions at the end of his presentation. Also, if you have any technical issues or other questions, please feel free to use the same chat window, and I will try to help you the best I can. Now, without further ado, I will leave you with this amazing session by Daniel Morgan. Dan, the room is yours.
Thank you very much, Francisco. Once again, to be able to present in a conference that you've hosted, whether it is in Latin America or APAC, always a pleasure. So thank you everyone for coming. I definitely appreciate you joining us today. If you are one of those few people in the US, it's late and we're going to still have some fun. If you're in the Asia Pacific region, good morning, and I hope you are enjoying this as much as I am, be able to get back and doing things like this. One quick addition to what Francisco said, when we talk security, often people have questions that they don't want to ask in a public forum. If you have questions like that, and you don't feel comfortable in the public forum asking them, I will have my email address here many times during this presentation. Feel free to write down my email address and you can communicate to me with a secure email directly to Oracle Corporation. So for those of you that know me, I'm not going to spend very much time on this. For those of you that don't, after years and years, actually decades of saying no to Oracle, finally in December had a weak moment and said yes to Oracle. I'm now with Oracle Consulting as Technical Director for Database Security, and I'm having so much fun. I wish I had said yes to them a long time ago. I'm a member of the Security Tiger team and Oracle ACE Director Alum, and beyond that, it's not that important, but it's on the slide if you wish to review it. What I want to talk about today is security, but there's a lot of confusion about security. And when I do things, if you're familiar with my presentations, they tend to be remarkably more technical than your typical Oracle Corp presentation. So I want to make sure that I lace a little bit of groundwork on what the definitions are for what's in scope for my presentation and what's out of scope. When we're going to use the word security here, we're going to use the word security from the standpoint of security. We're not going to be confusing it with auditing or audits, not with compliance, not with firewalls, not with governance, identity management, LDAP. Essentially, we're going to define Oracle database security as that which lies within the Oracle home or Oracle base directory, that which is for the most part inside of the database itself. So if you connect to a wallet, that's fabulous, but the security is not actually inside the database. The wallet is external. So I'm going to be very focused on what's inside and looking towards helping everyone understand how to build a very secure foundation underneath their database so that when you put on transparent data encryption, when you put on row-level security, when you put on LDAP, OID, all the other things that are incredibly valuable tools, you won't have a weak foundation on which you built your infrastructure and on which you've now put those tools. So again, if you have any questions for me, I'd love to have them in the public forum. But if not, there's my email address again. Please feel free to send me an email at Oracle. It will be secure. So the first thing I want to talk about, the number one topic everyone has who's talking Oracle database security now, who's really focused on the database, is how about ransomware? And it's a topic we don't hear much about. But this is an audience where I think it's appropriate to share some of the information that I have, which you probably are not going to see in a white paper or on a website, that talks specifically about two aspects of ransomware in the Oracle database. The first is, how can I harden my Oracle database to protect it from ransomware? And the second one is, now that I know how I can make my database more secure, can I use my database to protect other things? Could I protect PowerPoint slides or emails or Microsoft Word docs or financial spreadsheets inside of an Oracle database? And the answer there is yes as well. So first we'll talk about the database. Then I'm going to move over to how to, now that you've got a much more secure database from a ransomware perspective, how to protect other things. So when we think of an Oracle database, you've got a couple of different components. One is the one that you download from Oracle. You go to otn.oracle.com, you click on download, you click on Enterprise Edition, you download the file, unzip it, install it. Everything that you just did, you can recover by having that zip file. You can recover by downloading it from otn.oracle.com. There's nothing proprietary there. There's nothing that's customized and specific to your environment, to your data, to your database, to your organization, to your country. Everything else that you do thereafter, whether it's TNS names, whether it's listener.aura, whether it's the password file, whether it is doing alter system commands, whether it's creating users, roles, assigning privileges, inserting data, those are the things that are proprietary and the things that are of most value to you. You can't just recover them by clicking on a link at oracle.com. So let's look at this from the standpoint of, can I protect the file system itself? I unzip a file, it has to be in a file system. And the answer is no. Ransomware can get to that, and ransomware can make a terrible mess of it. There is one thing you can do to make that a little bit more secure, a little bit harder for an attacker to break into. And that's something that Oracle released in 12.1, enhanced pretty substantially in 18, and now it's been around so long and is so stable that it's now the default in Oracle 21 and beyond. And that's something called a read-only Oracle Home. So if you have made it to 12.1 or you're about to get to 12, hopefully you're on your way into 19 or are finishing your 19 migration, you have available to you a read-only Oracle Home. So look into that and look into, install the Oracle software, and the first thing that I want to do as part of that process is make sure I've configured a read-only Oracle Home. That's going to give you a little more security, but it is still on a file system and it can still be accessed and corrupted by ransomware. The other side of an installation, the part that's really important, which is the part that has your proprietary data and has all of the things that are specifically yours, your application, your password, your users, your table spaces, all of this can in fact be protected as of this moment from ransomware, and protected almost completely. And this is something that's really important to think in terms of. If you have an Oracle database on ASM, you don't actually have files. You don't have a file system and you don't have files. Oracle ASM presents itself as though it's files. And we say, oh, we have disk groups and we have disk files, and we have all these other things that make it look like, oh, there is a file that has this, my control file, or there's a file that is a redo log. But in fact, you're sitting on raw disk with ASM. And as of this moment, there is no known ransomware in the world that can get to something that's on raw disk. That doesn't mean it couldn't be invented at some point in the future, but at this moment, it doesn't exist. So to the extent if you have databases that are sitting on a file system and you take your data files and move them to ASM, build your control files or migrate your control files to ASM, redo logs, archive redo logs, standby logs, your SP file, password file, and RMAN backups, they will be, as of this current moment in technology, immune from all known ransomware, which means that anything that you've stored in them, you might have to recover the Oracle binaries. You might have to recover the Oracle home directory. You might have to rebuild a tnsnames.ora file. But your data, the most valuable asset that you have, is probably going to be completely untouched by all modern ransomware. So that's an important thing to keep in mind. There is a way to provide a huge amount of protection around those. Now, the other alternative, of course, is ZFS file system. I'm not aware of any successful corruptions with ransomware of ZFS. And the same thing with Oracle ZDLRA. But with any hardware, you should be able to go to ASM and run on raw disk and have that protection. The other thing that's important here in terms of reducing your risk is to remember that the Oracle database is the most, I don't even know how to describe it, it's probably the most granular journaling file system in the world. There is nothing that happens inside of an Oracle database that doesn't have a transaction number, doesn't have a system change number, doesn't have a massive amount of information that is journaled inside of the data dictionary and journaled into undo, journaled into redo logs, so that when changes are made, it's very easy to identify a specific transaction, a specific system change number, specific user. And from the standpoint of talking about ransomware, if I have that information, I also have the ability to roll back any transaction. So if I build a file system on Windows or I build a file system on Linux, there is no command available that I can just say flashback Windows file system or flashback Linux file system to before corruption. But when your file system's inside of an Oracle database, you can in fact flash it back to before corruption. So we think in terms of a database. Maybe we have a read-only Oracle home. We've got it on ASM. Oracle, many decades ago, or several decades ago, built something they called the database file system, which most people may be familiar with as DBFS, which is a file system inside the database. So you are, in essence, building your file system inside of a blob column, inside of a heap table, stored in a secure file table space, which means that not only do you have a working file system, and actually a file system that can in fact be corrupted, but because it's in an Oracle database, it's thoroughly journaled, it's thoroughly audited, and we have the ability to reverse the transaction that corrupted it. So if somebody gets into that database and gets access to that file system and corrupts it with ransomware and says for $100,000 or 100 million Bitcoins, you can have your data back, you can sit there and just say, well, we recovered it ourselves about 4 hours ago. Thanks a lot, but we don't really need your help. So let's talk a little bit about how robust the system is that I'm talking about. ASM has been out for 19 years now. If you've been working with it, for some people, ASM has probably existed the entire time you've been working with Oracle, because it's now 19 years that we've had ASM, which means we could do this on raw disk. We've had DBFS, database file system, now for 15 years. Oracle released it in 2007. So that technology is rock solid and has been proven for many generations of the Oracle database. If we look at more information about it, again, as I mentioned before, we can talk about the fact that we do have available to us system change numbers, transaction numbers. We have the ability to do RMAN backups, to do point-in-time recoveries, all of those things. But the flashback capability has been in Oracle since 1998, 23 years ago, which allows us to do things like flashback database, flashback query, flashback transaction backouts, and flashback version, and even look at the old version and the new version so we can get the exact system change number at which a corruption event took place so that we can roll it back. So 23-year history on the ability to flash things back if they become corrupted. And even in the DBMS flashback, fully documented and fully supported built-in package, we can get right down to the level of saying, I want to reverse a single transaction out of the database. Not like flashback database where the entire database rolls back. I just want to flash back the one transaction that was the event that corrupted my data. And you can do that this easily. And if you look at the upper box of syntax where it says options, binary, integer, default, no cascade, what this is allowing you to do is to say, I want to reverse the transaction. If you say cascade, let's say you had an insert statement. The insert statement fired a trigger. The trigger inserted something into an audit log. If I say to Oracle, cascade the reversal of this transaction, the audit record disappears too. If I say only reverse it if there's no conflict, or I can say no cascade, reverse this transaction, but my audit records are important and we're not allowed to change them, so no cascade. So you have incredible granularity here, down to the transaction ID, down to the system change number, and even in the ability to roll it back. Incredible amount of granularity. So all of these things add up to the ability to now build on top of RAC with DataGuard as a physical standby, with online redefinition, with rolling patches, resumable transactions, addition-based redefinition. We have all these capabilities that we can now roll into the so-called mundane thing of, oh, I want to store a file on a file system. And combining all of these things gives us the ability to be up 7 by 24 and to do all of the things that we've talked about here and either completely defeat ransomware or at least put ransomware in a place where we can reverse it without having to pay 1 Bitcoin for the passwords for doing that. So that's the ransomware part of what I want to talk about. Let's talk about secure configuration, because my focus at Oracle is not, gee, you really need database vault, or gee, you really need transparent data encryption, or gee, you really need identity management. These are all remarkably valuable tools, and I can't imagine running most environments without them because of the nature of what we tend to store in Oracle databases, requiring that level of security. But putting them on top of something with a weak foundation means that someone who is intent upon exfiltrating your data or corrupting your data or stealing your intellectual property is going to be able to bypass those things. You can put the best lock on the front door, but if you didn't put a lock on the back door, that great lock you put on the front door isn't going to provide you with that much protection. And this is very, very similar. So I'm going to be sharing some information with you, which is what we call emergent threats. That means some of the things I'm going to show you are not things that you can Google on the internet. These are things that we are seeing happening in the world as we watch, as our consulting practice is working. And what we're trying to do is to make you aware of them prior to you being on the wrong side of these attacks. So please treat this information as proprietary. Please do not share it outside of the group where you work and your information security people. We do not want to see this on Facebook. We don't want to alert people that we know some of what they're doing to break into databases. The other thing that is critical here to understand is that everything in this presentation that I'm going to show you now is inside of Enterprise Edition. Nothing I'm going to talk about involves getting anything that you probably don't already have deployed and licensed inside your organization. So let's go ahead and get started. The first thing I want to do is make sure that we're also grounded and on the same page in terms of who's responsible for database security. And I'm sure everyone's heard the story that Oracle's first customer was the Central Intelligence Agency. The second customer was the U.S. Federal Bureau of Investigation, the FBI. And the third customer was a group called Cancer Research and Biostatistics, which is part of the Fred Hutchinson Cancer Research Center. So it's sort of been spying, criminal detection, and medical records right from the very beginning, customers 1, 2, and 3. Oracle knew way back at the very beginning that they could not anticipate what was a secure configuration for their customers. There's no way for Oracle to produce a commercial product and say, oh, we happen to know how many logical reads per call you're going to have as a maximum, so we're going to set that for you. So what Oracle did, and this was all published and has all been very well documented, was to say, we're going to hand you a default profile. It's default because this is guaranteed to not, essentially to not create any backward compatibility issues for you. We're not going to break your application, but it's a default. And you need to now adjust those defaults so that they make sense for you, so that they work for your application. And different databases with different numbers of users, different types of work, maybe some analytics, maybe some graph queries, maybe some object queries, who knows, maybe even a heap table or two. And these days, your logical reads per database may be different. So go in there and change this. Unfortunately, what we find is that very few people have ever used the alter profile command. It's been there now for decades, but very few people actually alter that default profile. So the tools are given to the Oracle's customers, but we can't make you use them. We can certainly try to encourage you to do so. So that's an example of giving you the tools to make it secure, but it doesn't mean that we know what the right number of CPU or logical reads per call is. Another example, and again going back 30 years, then I'm going to get into the meat of the presentation, is sitting on my bookshelf right next to me. I have a copy of my old Oracle 7 SQL language book. And what I found interesting going through it was that 30 years ago, when Oracle 7 came out, Oracle included multi-factor authentication. Everybody's acting like MFA is this brand new, wonderful thing, and we should all spend huge amounts of money on it. But Oracle put it into the products over 30 years ago. Let me show you where. Create role. And you'll notice that under the create role syntax, it says identified by password or identified externally. And what Oracle wrote at the time, and I still have some of my old papers, was we're giving you this role called connect, another role called resource, and a role called DBA. This is for installing and configuring your product. But don't use the DBA role for your DBAs. Go create your own. Take those privileges that are escalated privileges like create user, grant any privilege, put those into a role for your DBAs and put a password on it. And even back then, when we didn't have people phishing passwords off the internet through email, the concept was still that it would take you one password to log into the Oracle database, and then it would take you one more password, plus you'd have to know the name of the DBA role that had been created so that you could get the privileges to do your work, but not to use the DBA role. So again, we're talking over 30 years of Oracle providing the tools, but letting its customers do their own configuration for what they wanted. Now, the group that I'm in right now, we're working on a project which is not available in Australia prior to tonight, but is essentially being released in Australia this evening. And so I'm using a recreational vessel checklist, because when you buy a boat, the boat is safe, but the people who sold you the boat don't know how many people are going to be on your boat. So they can't provide you with the right number of life vests. They can't provide you with the right number of fire extinguishers because they don't know if you're going to install a stove in the galley. So there is user configuration required, and your government in South Australia has a checklist. What we've done at Oracle Consulting is we now have a checklist as well, and our checklist is now over 770 items that we do as part of an assessment where we go through in a fully automated way, collect the information, and assess it, and then give people back reports. So it's very much like this. Everything I'm going to show you this evening is things that are part of that checklist, and they fall into a group of categories, and you can see some of the categories here and some of the details. But in total, it's more than 770 separate data points that can impact the level of security, essentially the attack surface for your database. So part of the reason we're doing this is a lot too many of people are, and their organizations are relying on firewalls to protect them. When we go out into the real world and we start evaluating what some of those firewalls actually look like, this is some of the stuff that we really see. This is from 2 different organizations. These are really untouched firewall rules. The only thing I did was put in the red colors because we all know that red is bad and green is good. Where firewall security policies had literally been going from untrust, that means the internet, directly to business data, that means Oracle databases. So firewalls configured to allow outsiders on the internet to go directly into Oracle databases. So lots of ways people can get in. We want to make sure that you know how to protect yourself from them. So the first vulnerability I want to talk about is in-memory rewrite vulnerabilities. There are 3 of them that I'm going to show you this evening. And you probably are aware of the concept of rewrite, but not rewrite as an attack mechanism. So the first time any of us saw rewrite, we were probably working on the rule-based optimizer. If you're a dinosaur like me, you were working on the rule-based optimizer, and you used some hints to say, use a nested loop, use a merge join, use this index, don't use that index. We also later on found Oracle changing the way query rewrite worked and expanding it a bit and saying, if you query a table, but there's a materialized view or a snapshot that already has the results, query rewrite is going to go and ignore the query that you just wrote, and it's going to go grab those same results, but it's going to grab them out of the materialized view that's dependent upon that table. So we've had those capabilities, and none of those were especially dangerous or threat or capable of being used as a threat. But starting with 10.1, 12.1, and 12.2, Oracle built in some incredibly powerful features. And these are incredibly powerful from the standpoint that you can use them to do incredibly wonderful things. But being as powerful as they are, they're also subject to being used in a different way. So I want to go through all 3 of them for you. The first one's a built-in package, fully supported. It is in the packages and types documentation and has been since 10.1. And it's called Advanced Rewrite. So you can use the DBAs Advanced Rewrite package, and you can find, let's say it's a query embedded in a Java application or embedded in a C++ application where you can't fix the query. And you talk to the people that you bought the application from, and they say, yeah, we'll patch that, but not that many people are complaining yet. But meanwhile, you're complaining a lot because it's not running very well. So this was added, and it allowed us to do something really, really wonderful. It allowed us to, in memory, inside the optimizer, swap out a SQL statement with an equivalent SQL statement. So I could have the one that came in my application, which performs horribly, uses a lot of resources, and is slow. And I can have my senior developer write a better query, run it through testing, and say, fine, let's swap it out. But now let's look at that same swap it out capability in terms of what it can be used for. I've got a table here, and red is bad, green is good. So if somebody can get to the whole credit card number, that's a bad thing. But if they can get to the final 4 digits of the credit card to validate it, that's a good thing. So we've got this marvelous system. We've got Oracle Audit Vault. We have Oracle Database Firewall. We have tripwires on our network. We're monitoring the SQL that's going to the database. And we see this query go in that says, give me the final 4 digits of the credit card number. And that's what we're monitoring. We're monitoring the SQL that's going into the database from the application. And what that sees is exactly what it's supposed to see, the perfectly legitimate query for the final 4. But if I declare a rewrite equivalence, and you notice here, I've got the in green in the middle box, select the credit card final 4 from the credit card table. That's my source statement. That's the statement that I want to make go away, and I'm trying to steal your credit card data. So anytime you ask for the final 4 digits of the credit card, I'm going to substitute the select statement I wrote. I'm going to grab the entire credit card number. And in fact, if I wanted to, I could concatenate the expiration date and the CCV number and the postal code of the person whose credit card it is, and all kinds of other fascinating information. And because it's going for the credit card table and it's a select statement, it will most likely pass through without being validated. And as you can see at the bottom box, I selected the final 4 of the credit card, and it gave me, and if you look at the header, it says CC final 4 above the dashed line, but it's in fact returning the entire credit card number. This is the way it has been misused. This was done in, let me check, 10.1. When we get to 12.1, Oracle got even better at helping us with performance issues. But before we get there, let me show you the kinds of things that we're doing for our customers now when we're doing these security assessments. We're giving them the following information. We're saying, okay, you've got advanced rewrite in your database. Undoubtedly you do, because it's been in every database since 10.1. It's owned by SYS with no privileges granted, which may make you feel pretty good. But the question is, are you auditing executes on advanced rewrite? What we're finding is most people are not auditing the grants on that package because they're not aware of the fact that it can be used as an attack vector. Are you auditing all executions, successful and unsuccessful, if somebody does use it? Because keep in mind, it's owned by SYS. No privileges granted, but that doesn't mean somebody couldn't get in as SYS and use it. We're providing information on the underlying data dictionary table, in this case some $, and which columns have the information you'd want to monitor, and also providing information on what to tell your internal auditor, so if they see it in use, they're not going to ignore it. They're going to understand that this is not something that's supposed to be used. So let's go to what Oracle then added in 12.1, which takes that advanced rewrite capability and makes it substantially more dangerous. More powerful for doing good things, but more powerful also means more dangerous in the wrong hands. Oracle added DBMS SQL Translator. And SQL Translator can literally translate any SQL into any SQL. And it doesn't necessarily even care whether it's valid SQL. You can translate Transact SQL into PL SQL, for example. So it's going to go into the optimizer, and it's going to transform it inside the memory on your database server where nothing can monitor what it's doing. You're going to, again, give it a source, which is the SQL text. I've got it in green. Give me the server ID and from our servers table. But in this case, I don't have to replace a select with a select. I can replace a select with an insert, or a select with an update or a delete. So I can create different data. I could call a function which contained a call to util SMTP and email that data to an email address halfway around the world. I could also use this transaction to corrupt data with an update statement or delete data. Lots of opportunities here for mischief if someone wanted to. Now, whereas advanced rewrite had no privileges granted, SQL Translator being a little newer, is using a different security algorithm within Oracle. And here, execute's been granted to public, and you're thinking to yourself, this is horrible. Why on earth would Oracle grant something like this to public? And the reason is because the way Oracle went about securing things was to try to be a little more nuanced about it. So while I'm going to say, yes, you should definitely revoke execute from public, and if somebody needs it, grant it explicitly, but Oracle looked at this from the standpoint of trying to be more fine-grained, trying to provide more capability to the customers. So you can have execute on it, but the DBA hasn't granted you the create any SQL translation profile. So while you can theoretically create it, you don't have that system privilege, and therefore you actually can't do it. But it means that now not only do we have to be concerned about the package, but we need to be concerned about who can create a translation, who can alter the translation, and who can use the translation. So again, more power, but more risk. So we provide in the report the information again on which table to monitor and what to tell your auditors about the possible misuse of this. The third form of rewrite I want to show you is something called SQL patching. Now, SQL patching has been in previous versions of Oracle before 12.2, but before 12.2, it was in an undocumented, unsupported package, which almost nobody even knew existed. In 12.2, this was moved into SQL Diag. And why SQL Diag, I can't answer, but what a SQL patch is the ability to hint SQL that you can't get to. So again, it might be SQL embedded in an application in Java or in C++, where you as a DBA or developer, third-party application, there's no way you're getting to the source code and rewriting it or hinting it. So in the example I've got here, I'm taking a SQL statement that uses, and you can see it in green here, a bind variable. And I want my query and I want the optimizer to be bind aware. I want it to go and do a lookup on that bind variable and say, okay, it's 12, now I know what to do with the statistics. This ability to do that cannot allow someone to corrupt data or create data or manufacture data that's not legitimate. But it can be used for a denial of service and attack. And again, I'm showing you things that are unfortunately happening. The way that the ability to hint SQL could be used as a denial of service attack, you can see here. For example, I could say, I'm going to add the following hint to the SQL statement. And this is a mission-critical SQL statement, and it has to complete in under 3 seconds. Or every one user in our entire system is going to be furious. I can say, oh, let's force a full table scan. Just to make sure the optimizer doesn't try to end run us, we're going to tell it that under no conditions is it to use the primary key index. And, oh, by the way, optimizer, don't get smart and try to do any parallel processing, because I've also given you the no parallel hint. So essentially, hinting to create a denial of service attack, to slow things down and to create chaos. So again, we're looking at what can one of our customers do. Again, execute is granted to public. In this case, Oracle protected it with the advisor role, or actually it's the advisor system privilege. I'll have to fix that. So the fact that it's granted to public is not that huge a danger, but if you aren't aware that the advisor role or advisor system privilege is required, you may not realize that somebody can ask for the advisor privilege and you think that they're going to go look at the undo advisor or something else, and they might in fact be doing a denial of service attack, something you would never equate with having the ability to look at an advisor. So we're recommending people revoke execute from public. If somebody needs access to SQL Diag, grant it to them explicitly. Grant any audit any grants of SQL Diag execute privileges. Also, make sure you're auditing anybody who's using the advisor system priv. And watch for use of this, both successful and unsuccessful. Finally, again, make sure your auditors know that somebody using SQL Diag may be perfectly legitimate, but if it's related to a denial of service attack, you're going to want to draw a straight line between those two things. Another piece of the puzzle that Oracle added, again, in the neighborhood of 30 years ago, that is really important to security of your databases, is a totally supported, totally documented built-in package called DBMS Distributed Trust Admin. As you can see from the header in the file, it was created in 1996, renamed in 1997. It's been around for a very long time. Oracle finally released it in 9.0.1. And the reason Oracle created this was that as they became more aware of how people could misuse this product that they created, they started going through and adding additional capabilities. And the problem that DBMS Distributed Trust Admin solves from a security standpoint, and this is the only thing it does, is if I give someone the create database link privilege, I can't stop them from creating a database link to any other database where they have privileges. Doesn't mean they have permission to create the link, but it does mean that if they've got privileges on that database, I can't stop them from creating that link. So Oracle thought this is probably not the best thing in the world, and they released this. And again, go to the documentation. You've been looking at it now for 30 years in the docs, but probably never run it. And by default, if you go to trusted list $, the underlying data dictionary table, you're going to see that Oracle + is trusting every single operating system, container, or VM in your entire environment. If somebody's got create database link privileges, this isn't going to stop them from doing it. What we're suggesting is go back, and even though this is version 9 stuff, it's really probably a new feature to almost all of Oracle's customers, and review the database links that have been created, make sure the ones that are there are legitimate and are in use, and then go through, as you can see in the third box at the bottom, and grant and allow server. So I'm saying I'm allowing this particular server to be accessible to a database link. Now, somebody with create database link privileges can create one or more links to that environment. As soon as I've got everything explicitly called out, go through and do a denial. And the denial means that for anyone to create a database link to any new servers in the future, they are going to have someone go in and add that server to the trusted list. So very simple one-line command. You can go from trust all to deny all, or allow all to deny all, and substantially reduce the attack surface for your database. So from a reduction report standpoint, we're providing customers with the information on what to do in terms of this package. It's owned by SYS, and it executes only granted to the execute catalog role, which sounds really safe, except that it's then from the execute catalog role, then granted to the SYS user who owns it, so it doesn't matter much, to the DBA role, to the export full database role, and the import full database role. Why somebody doing an export full database would need to be able to change the trust of a server, we haven't figured out yet, but that's how it was granted. So we want our customers to be aware of this and to be able to make these changes and to protect themselves and their databases. If you haven't made it to Oracle 21 yet, you probably have heard a little bit about blockchain tables and immutable tables, but you haven't built any. We're finding now that it's been backported into 19 that a lot of our customers who are interested in security are in the process of moving certain tables into blockchain tables and immutable tables. So let me talk a little bit about what these new types of tables are and why these are so incredibly valuable. Blockchain tables, if you think in terms of Bitcoin and having a blockchain where all transactions are recorded, This is an Oracle heap table that does essentially the exact same thing, allows you to create a blockchain of transactions, a ledger of transactions where the dependencies and the relationships are maintained. And this is done using some invisible columns and some very, very nice 512-bit encryption. What makes these the most powerful things for a lot of organizations that are interested in keeping ledgers that cannot be tampered with or audit trails that cannot be tampered with is if you look at the syntax on the upper left, no drop until a certain number of days idle. Suppose I create that table as I've done on the lower right with 365 days idle. That means no DML transactions in that table for 1 full calendar year before that table can be dropped. No delete until a certain number of days after insert is essentially saying, in the case of the example I've got here, until a row has been in this table for 95 days, you cannot delete it. And I've had people go, well, yeah, but I can do a workaround around that. I can beat you. And I said, fine, you think you can beat me? Go ahead. So the only difference in the syntax between the blockchain table and the immutable table is that the blockchain is protected with the SHA-2 512-bit encryption. Let me show you how secure the records in these tables are. And I personally spent about 3 hours trying to break it myself and got really, really frustrated that I couldn't figure it out. I was doing 10046 level 12 traces, could not come up with a way to do it. Even went into DBMS metadata and reverse engineered the DDL to build them, could not come up with it. So I created a immutable table. I put some data into it and I said, I want to update one column. Sorry, not going to happen. No update statements allowed. How about no delete statements allowed? No truncate statements allowed. I can't drop the table. I sort of expected that the drop table wasn't going to work. And I thought, well, now I'm going to try to figure out how to beat Oracle. So I tried to rename the table. It appears you can't rename the table either. And then I said, well, you know, I built this table and this has been a fun exercise, but I need to make it go away and I can't drop it. So what am I going to do? And I thought, well, I'll just move everything else into another table space and I'll drop the table space. And I was wrong because it won't let you drop the table space either. So I now have, I built this in February, a table called audit records. I can't drop for 365 days, which means next February I'll get to drop the table and the table space that it's in because there's no other way other than to do a drop database. And that means an offline drop database. I can't even do a regular drop database. I've got to take the database down and literally clean out the file system. So these are remarkably safe things to use from a security standpoint. We have a built-in capability that was moved from DBMS system to DBMS log in version 12.1 that impacts security. DBMS system was undocumented. So is DBMS log, but the fact that Oracle moved it caught some people's attention. And I want to show you an illustration of how this has been used maliciously in the past. What the built-in capabilities of what was DBMS system and is now in DBMS log is it allows you to write things to the alert log. And you can write anything you want to the alert log. So for example, I can flush the buffer of any pending messages just in case there are any. I can put in a date timestamp so it looks like it's this really official Oracle stuff. And I can say, I want you to write Aura 600 and then provide a message to the poor DBA that says, look out, too late, something bad just happened to your database, you're toast. Then I'm going to follow it up with another message that says, open a Sev4 service request with Oracle support. We all know Sev4 is the lowest priority, so it's probably not going to get responded to quickly. Something that probably would work quite well in Australia, certainly works well in Denmark. Start drinking beer, and after the 7th beer, run the following SQL statement, drop the standard package. Now, what actually happened that we observed was that somebody wrote a message for a monitoring program, and the monitoring program shut the database down. So they knew what it would take to shut the database down. They wrote something into the alert log. The monitoring program saw this thing in the alert log and immediately aborted the database and took it down. It was not nearly as much fun in reality as they thought it was going to be. But that's the danger of giving access to this particular package, is that can be done. So again, we've got information on what to do in the attack surface reduction report, and you'll get a copy of this slide deck so you'll be able to read this. Also in Oracle 21 and future versions, unfortunately not backported into 19, is a new file called the attention log. We've had lots of problems with too much information in the alert log. Too much information at risk when people can get to the diag directory. So we've come up with something new called the attention log. And the attention log can be written to the diag directory. It can be written to other locations as well, including a log directory, as you can see here. And the idea is to provide the critically important information that used to be buried in thousands and thousands of rows of alert log in a format that's human readable and human understandable, as well as machine readable. And what the attention log is a formatted log, and I've just got two examples from it. One is a normal notification. You started the database. Instead of waiting through every single process starting up and its PID, how about just saying, here's the operating system process ID. The urgency is this is just informational. The command startup was executed. Here's the time when it was executed. And the person in your organization that needs to know it is your CDB administrator. Because keep in mind, once you get to Oracle 21, everything's a container database. So that would be the CDB administrator. This particular capability has a group of categories of urgency and of causes and of actions and of classes, so that messages are not just easy to read and easy to understand, but the messages identify who in the organization hierarchy with what particular task is responsible for addressing that message or needs to possibly be aware that that message exists. So I forced an error just so I could get one, just to show you. And here you can see the error. I did manage to produce an error. It's an Aura 00495. The urgency was immediate. The instance termination routine was called. It doesn't say how I did it because it didn't know. And it's suggesting here that you check the alert log for more information, at which point you would find out that I did it. But gives you a sense, again, of how the attention log will be substantially more valuable to DBAs and to other tools that are monitoring an Oracle database without exposing any confidential information, which is why I wanted to put this back to back with the alert log. The alert log is far too much information for the overwhelming majority of tasks, which are really routine. Start it, stop it, maybe patch it, maybe back it up, and yet we're exposing massive amounts of information. So once you get to 21 and above, move yourself from the alert log, which you've got years of experience with, to the attention log, and it will make things a lot happier for you and a lot more secure as well. Let's talk about a couple of things that are in here. I'm not going to go into them in detail because I'm watching the clock. If we do have a little time, I'll come back. But these are things that you want to make developers in your organization aware of. The first one is the accessible by clause. We have found that having schema level protections is insufficient. And with a lot of applications, if I give somebody the ability to log on to the accounts receivable or the general ledger or the HR application, that I can't protect a particular function that does hashing, or I can't protect a specific routine that does things like a credit card analysis or a fraud analysis. We had the need to be able to protect at a level that was more granular than just the schema. With the accessible by clause, you can take a PL SQL object and you can make it so that it cannot be called from SQL Plus by anybody. We're not talking about database vault. We're not talking about system privileges. I can grant you execute on it. It's not going to make any difference. If you're sysdba and I say accessible by only this one function, there is no power other than being the person who has access to that one function that's going to ever let you do it. Let me give you an example of what this would look like. Here I've got a very small built-in package called OCS Utilities. It's got two functions in it, one called getSeed and the other one called getName. You notice the syntax of these functions is exactly identical, but the difference is that one of them says it can only be accessed by a stored procedure named driver. And if you build these, and I've got the source code here and you're welcome to do it, what you're going to find is that getName can do this, and that the getSeed is not callable. Both of them work perfectly if you get to them the right way. So here I say getName, no problem, I get the name. But getSeed will produce an insufficient privileges. So it's the same package. I can get to one function in it, but I can't get to the other function in it unless I know that I have to call the driver procedure. And the driver procedure can, in fact, get to getSeed and return the seed value. So accessible by is an incredible ability to secure PL SQL objects. And even within a PL SQL package, as I showed here, I can either protect the whole package or I can protect specific pieces of the package. And I could have every single function and procedure inside a PL SQL package have to be called by something else. They don't even have to all be called by the exact same thing. So it's extremely granular. And I could do a comma delimited list. I could say accessible by the procedure driver, comma, XYZ, comma, Morgan, and again, remarkable power here. Another one that is important for developers to be aware of in terms of security is code-based access controls, which were brought in with 12.1, but unfortunately we find these days that most developers are probably further into their particular language like Java or C# or whatever, and not necessarily paying attention to the security aspects of the Oracle database. What code-based access control allows us to do is to create roles, just like the roles that we've always had, roles that have system privileges, roles that have object privileges. But rather than granting the role to a user who could potentially misuse that privilege, we can now grant the role to an object. So I can created a role here. I've granted read on the user history table owned by sys to my role, and now I'm granting that role to a package. What I've said is that no user, I'm not giving any user, I'm not giving any human or service account access to the user history table. Too important to keep that secured. But I do have a PL SQL package that needs to be able to access the user history table. So I'm granting that read privilege to the package, but no user can take that read privilege and exploit it. So again, something you want to make sure your developers are aware of, and stop granting privileges to people. Think in terms of granting them to the objects that actually need the privilege. Unified auditing, I want to go into unified auditing. It's been in the database now since 12.1. It's being greatly improved, and additional capabilities are being added as we move forward. But there's another reason why I want to do it, or actually a number of reasons I want to do it. Essentially, when you create an audit policy, rather than saying audit this one thing only, and then I have to say audit some other thing only and audit this, and I build up maybe from 50 or 100 separate audit statements, the look and feel of what I want, and now I've got to go duplicate that in database after database or PDB after PDB. A policy is an object. So within a single policy, you can grant privileges, you can grant roles. There's a when clause, so you can determine when to use it. You can fine-grain it in terms of containers for a container database. You'll also find that Oracle has now put in RDBMS admin directory, and if you haven't seen this file, I encourage you to open it up in VI and read it, because it's a very, very interesting file. It's secureconfiguration.sql, and in it, it includes the policy recommendations from Oracle if you want to comply with the Center for Internet Security guidelines for audits. You want to just pass their audits. You don't want to try to figure out what it is we need to do in auditing. Just apply the CIS policy. Or if you're in a military or other government functionality in the U.S., we have something called STIGs, Secure Technical Implementation Guidelines, that are published by the Department of Defense and the U.S. military. And that policy recommendation is also in that file. So you can run those files, you can cut and paste those pieces out, you can use them as a starting point and make modifications to make them correspond to what you need in your country. But another good reason to looking at unified auditing. Here's some examples of some of the things that you could use in building a policy. I can audit the use of a role. I can audit the use of data pump. I can audit a number of different things like updates, deletes, and inserts and selects. As part of a policy, I can audit attempts to query the audit trail to see if anyone's querying the audit trail and trying to figure out what's going on. I can take all of these things and combine them into a single policy. And as you can see here, I can even throw regular expressions into this. So the audit policies are extraordinarily powerful, extraordinarily flexible. And here's an example of, I think I had to remove some of the lines from it. So this isn't the complete one. Go to secconf.sql. I don't trust this, but it's an example of the audit policy for the U.S. Department of Defense, where you can see some of the ways this has been put together into a single policy. And at the bottom, you'll notice the execute on DBMS job, to execute on transparent sensitive data protection. You would want to probably add into there DBMS SQL Translator, DBMS Advanced Rewrite, some of the other packages that we've been talking about here, and build those into the policy. Finally, I'm not in a position with Oracle Consulting to talk about the Oracle roadmap forward on auditing, but I am in a position to tell you something that will be of importance to you as you're thinking in terms of being in legacy auditing right now and moving forward and deciding what do we want to do in terms of auditing. There's fine-grained auditing, there's legacy auditing or basic auditing, there's the new audit policies. The following objects were present in 19C and have been deprecated or desupported in 21C. And while I can't tell you what the roadmap forward is, I think I can safely lead it to everyone to look at that information and make a good decision for themselves. So I can't tell you what's happening, but I can tell you that those objects no longer exist in 21C. Let's talk about password rollover. Password rollover is something that was added in 21C and was so instantly popular it was backported to 19.12. One of the biggest issues that I have confronted over the years doing security has been people who don't change passwords. And usually the excuse for not changing passwords is, well, it's the application. And if we tried to change the application password, we'd have to change it in 100,000 places. And we only have 2 people who can do it, and they only work part-time. And it would take us forever to change it. And we'd have to take this massive outage. So, yeah, we change passwords on some things, but we can't change those passwords. We just sort of live with the risk. Well, that's no longer the case. As of 21C and now backported to 1912, and I would expect almost everybody attending this conference has databases that are either in 1912 or will be very soon. We have the ability to have a user with 2 passwords at the exact same time. So let's say my application's current password is the word secret, and we decide secret is not secret enough, and we're going to change the password to PWD123. Well, nobody's going to let us take an outage to change secret to PWD123, so it stays secret. We get broken into. If I go in and I set a password rollover time of 3, and by the way, the integer is days. It's not hours, minutes, or seconds. So what I've done is I've said, now we have 3 days in which both secret and PWD123 are both valid passwords. So I can start off by going to my first app server and saying, okay, we're ready to change the password. I call up the DBA, and the DBA goes alter user application identified by PWD123, and every single app server that's currently using secret is still going to continue to work for 3 days. And they can roll over the first app server and the second app server and the third app server. And when they roll them over to the new password, they're all going to work perfectly because both passwords work. And at the end of 3 days, exactly 24 hours times 3, the old password will be dropped and will no longer be valid. And you don't have to do anything. It goes away all by itself. So this eliminates what has been a huge issue that I've bumped into for many, many years, which was the database password that everybody said you couldn't change. So now that excuse is gone. They can all be changed, because you can say, we're going to take 1 day, 3 days, 5 days, 25 days, whatever it takes. But you can now have 2 passwords simultaneously. Got a couple of other things here, and then I'm going to get into wrapping this up, so we should end right on time. And that's denial of service attacks. We talked earlier about the ability to use the DBMS SQL diag package to perform a denial of service attack by hinting in the worst possible way and saying to the optimizer, everything's a full table scan, don't use the primary key indexes, and no parallel. Make things slow. But most denial of service attacks that we see in the wild are actually self-inflicted by people's own application connection pools. What happens is they'll have a connection pool that when it comes up tries to create 2,000 users. And guess what? Somebody misconfigured the password on one of the app servers, and when the app servers come up, it's throwing this bad password, which is getting rejected. And it's a connection pool, and the connection pool says, well, I'm supposed to have 1,000 connections. And it just keeps trying and trying and trying, and it creates a flood of connection attempts, which ends up looking an awful lot like a denial of service attack to those people who are trying to get in there and do some work, or those people who are connected who don't have any resources. So in the syntax for the listener, and you'll find it in listener.ora, is something that allows you to tell the listener to limit the rate of connection attempts. So I can say rate limit yes. And now the listener is going to say, this is good. I'm going to monitor the number of connection attempts per second. And if it exceeds a value, I'm not going to send them to the database. So in fact, the listener is taking the hit, but the database itself is protected. So you aren't having a denial of service on the database itself. People who are there can continue to work. I can fine grain the way I do this. I can say connection rate listener 10. So I can get a maximum of 10 connections per second to the database. And it's going to limit it on ports 1521 and 1522. But 1523, yeah, we don't care. If they want to take that one down with another service attack, go for it. So you can very carefully fine grain this. And this is, again, one of these things where you can configure this to work for you. But by using this, you can make it just about impossible for a connection pool to ever do denial of service, but also an attacker cannot do a denial of service because the database itself is being protected. So I'll talk a little bit in wrapping up about the attack surface reduction assessments that we're doing. We've launched this in the US, but I have been told we can make this available in other countries on request. Otherwise, you will probably not hear about it. So just give you a little background on what we've done. The people who are trying to compromise databases, the professionals in countries that you can name, I don't need to, are spending 8 hours, 10 hours, 16 hours a day at work, getting paid to do nothing other than figure out how to break into your databases. You're probably going to work for 8 to 10 hours a day, and some of that's spent at meetings, and some of that's spent doing all kinds of other things, but it's never a solid, your entire focus is to protect your database. So we have a cadre of people who are focused on breaking in, and all of us doing lots and lots of things trying to keep them from being successful. So what we've done is we pulled together a team of experts from inside of Oracle, and some of them in support, some of them in product management, development, some of the members of the Tiger team and the OCS security group, gone through a lot of the frameworks that are out there and looked for what are the vulnerabilities. And some of the ones that we're aware of are things that could potentially be 0 days and are being worked on to be patched before they ever get there. The majority of them are things where you could just come up with the wrong configuration and, in essence, not be as secure as you really should be. So, for example, granting the DBA role to someone rather than creating your own DBA role. You're definitely in far less secure because you're granting privileges that nobody actually needs. I've yet to find anybody who needs the privilege under any table. A couple of times when I've had too much to drink, I've been there, but I've never really felt like I had the privilege to do that. So we're collecting information. Some of it is being collected with question and answer. Some of it we're collecting is from files like the SP file, like SQLnet.ora, cman.ora, LDAP.ora. Some of it we're collecting from looking at basic data dictionary tables, $, $V$ objects. We're analyzing it, or I should say importing it into a fully encrypted system. We are analyzing that data with an expert system written in PL SQL, and there's a couple of other bits of other languages in there as well to help do some of what we need to do. Having some human eyes on it, and then preparing a report for our customers and destroying everything that we collected from them. I want to give you some examples of some of what's in there, and then there's another vulnerability in here I want to call out for you. Clearly, you can see from our discussion of DBMIS distributed trust admin that one of the things that we're catching here is under database name, it says plus asterisk, so that means they can build a database link to anywhere. And we're going to advise them to change that to deny. We're also looking at unwrapped source code and wrapped source code that's in DBA source or CDB source or source $, and specifically looking for PL SQL packages that customers have created that were not wrapped, and recommending to them that they need to wrap those packages to increase the security. We're looking through initialization parameters. I'm sure a lot of people are using Oracle encryption like TDE, transparent data encryption, which is incredibly powerful capability, or using the DBMIS crypto package, or doing cryptography on backups. You're doing encrypted backups, encrypted data pump extracts, doing encrypted real application testing files. What a lot of people are not aware of is that there is encryption and then there is encryption. And the difference between the basic encryption and the higher quality encryption is a flag that's built into the database called DBFIPS 140. By default, it's set to 140, so you're not getting the highest quality encryption by default. So for a lot of the customers who we know are using encryption, part of what we're identifying for them is that they could do an alter system, they could change that to true, and they would have a much harder to break encryption coming out. We're catching violations of Center for Internet Security protocols, for example. They recommend against using trace for the security protocol error trace action. So these are things. But the one I want to show you, which I think is really important to indicate the level of what Oracle Consulting is now doing, is we have gone through and analyzed every underscore parameter in the Oracle database in every version from 12 up. And if you want to go and have some fun, there's the SQL statement for looking at it. What we're looking at is things that are underscore parameters where somebody attacking might want to make a change to your database to make it easier for them to get access, to escalate privileges, to compromise and exfiltrate data. And I thought I'd show you 3 of these that we are calling out as part of our assessments. The first one is disable temp encryption. I can't think of anybody who would voluntarily want encryption in their temporary table space disabled. By default, it's enabled, but there is a switch in there that could allow an attacker to disable the encryption in the temp table space. So part of what we're monitoring is to make sure that nobody has flipped that switch and disabled that. Another one, which is the exact opposite, which is that there is also an underscore parameter that allows you to restrict access to $$ and $GV$ views inside of a pluggable database. It doesn't happen in the CDB route, where presumably a DBA would need access to all the resources that are available. But when you get into a pluggable database, there's far less need for accessing some of these things that can compromise data and compromise information. By default, it's set to false. So in a PDB, you can see the exact same $$ and $GV$ views that you can everywhere else. By changing this to true, the number drops by about 80%. So again, it's not a perfect solution, but it is reducing the attack surface. And another one is by default, trace files are considered private by the application or by the database. So are trace files public? False, no, they are not. But somebody who wanted to gain access to your trace files as a way of getting information that would help them finish an attack might really enjoy the fact that your trace files were in fact publicly readable. So again, something that we're checking to make sure that our customers are well protected is we're looking through this one and making sure that it stays false, that it hasn't somehow gotten changed by some activity that might have happened, an hour earlier or a year earlier or something like that. So we've got 40 of these that we've identified, and just wanted to share with you some of the things that we're looking at right now in terms of trying to help our customers achieve the most secure possible environment for their databases. So doing the analyses, I'll give you an example of the kinds of conclusions we're drawing. We might look at an Oracle database and see that by default, util TCP has been granted to public. That is in fact the way Oracle database is installed by default, because again, we don't want to break anything that might be in use by an application. But we're also going to look at network access control lists within the database to see if anybody has created a network access control list or a network access control entity which would limit that util TCP usage to perhaps going to a single internet address or to a single socket somewhere. We're also going to look at whether if someone has a container database, they have perhaps created a lockdown profile, which again could be used to limit access to util TCP. So having access to util TCP is a concern, but you can protect it with network access control lists. You can protect it with lockdown profiles. You can be aware of the risk and be monitoring it with auditing. So we're looking at all of these things. And then coming back to our customer and saying, for example, we notice that you've got util TCP, execute is still granted to public. Since you're not using it, we're going to recommend that you revoke that access from public. Alternatively, if you don't want to do that, you could create a network access control list. Alternatively, you could create an audit. You could create an audit policy and make sure that you're carefully monitoring any usage that might occur. So we're providing essentially the full menu of options in order to make sure that you're aware of the risk, you're monitoring the risk, or you're locking down the thing that's creating the risk. Producing reports and then going out and making these reports available to our customers so that they can go and do those configuration remediations themselves and address those issues. So that pretty much sums up what I've got, and want to say thank you. And I'm going to drop out of the slide deck for a second here and see if I can get back to where I might be able to see questions.
Hi, Daniel. How are you?
I'm just fine. I'm at a loss to see where with this interface I would find any questions, if there are any questions.
Yeah, good. It's in the chat window. I can read one that I have for Jean Leong. How does flashback deal with subsequent transactions that were dependent on the original transactions?
Your choice. You can, let's say I have a transaction that is an insert into an audit table, and I have a transaction that it was dependent upon. So you did an update statement, fired a trigger, wrote something into an audit table. So there's a dependency on the update statement. I could roll that back if I have a separate transaction number for it. They may be part of the same system change number, but depending on how they've been coded, they could have separate transaction numbers. If they don't, if it's a single transaction, then it's going to roll back together. So let me give you an example of how they could be separate. Think in terms of Pragma autonomous transaction. I often, just because my audit logs often, I want to make sure that they will commit even if something goes terribly wrong. I will sometimes write my logging using Pragma autonomous transaction, so it's a separate transaction. When you do that, you are opening yourself up for the fact that you could reverse the audit transaction separately from the original transaction. But for the most part, people will say, insert this, fire the trigger, do that, and at the very end they'll say commit. So it is one transaction. Does that help?
Just waiting for Jim to see if he has any other question. And in the meantime, I'm just checking the Facebook streaming too, if there's any questions over there. Now, looks like there's no more question coming. If anyone has any question, please feel free to add to the chat window. Also, if you're watching the replay in the platform, you have Daniel Morgan contact information on the screen at the moment. And if you don't want to ask questions also in the public forum, you can also ask him directly by email. This Jim Leong also asking, Daniel, is possible to get this slide deck?
You will have it before I go to sleep tonight, which, given the time here, means you will have it very soon.
All right. Thank you. That way we can share with the team too. All right. If there's no more questions coming, I would like to say thank you to everyone. Thank you so much, Daniel, for taking the time. I know it's late for you to share your knowledge with the community, not only Asia Pacific, but all around the world. And please take care and be safe, everyone.
Thank you very much, Francisco. Thank you, everyone, for attending.
All right. Thank you, everyone. the playback will be available in 24 hours. Cheers. Bye-bye, everyone.
Bye-bye.